calculator. I need to turn my calculator on first, and then I can do all the work without having to see all the keys. Okay, so stats, edit, and I want to take the information that I have and put it into list number 1. I'm leaving my list number 2 there. If you put your exercise that we did before in list number 1, nothing says you have to keep that list. You can erase it and continue to reuse list number 1 over and over and over again. So if you want to erase it, remember that you can put your cursor up into the label, you can press the clear key, you can press the down arrow, and the list goes away and you can reuse the list. Or you can leave them up there as long as you want. Okay, so this is as simple as typing. The only thing I can do that I can verify at this particular point in time is I have typed 12 pieces of data. Whether they are the 12 correct pieces of data or not remains to be seen when I scroll back through and look to make sure that I haven't screwed them up somewhere along the line. I can't see them all by going up to the label. I can't see the whole list. Okay? So you have to scroll somewhere along the line to double check your data. Once the data is in, you're going to run one variable statistics. So you go right back to the stat key. Do not have to go to the home screen. You go right back into the stat key. Slide over to the calculate column. Select one variable statistics and tell it what list you want it to use. Some of you are forced to do that with the new 84s. Those who have the older 83s, I still would like you to get into the habit of telling the calculator which list it is, because if you're not used to that, when you put it in the wrong place, you'll send it looking someplace else for a list of data. Okay, so I'm using list number 1 for my data. And that's going to process all the work for me. First screen. Nothing on this screen is part of the 5-number summary. Nothing. But it's very valuable information that will be useful later or other places in this unit, in this particular topic of central tendency. 5-number summary is the second screen of data. So automatically scroll down to the second screen and copy your information. Minimum value, 10. Quartile number 1, 25. Median value, 31. Quartile number 3, 45. And maximum value, 88. Now visually, I have 12 pieces of data, right? 12 divided by 2 gives me 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Does it make sense that the median value was 31? Now I have 6 values over here. 6 values divided by 2 gives me 3. 1, 2, 3. 1, 2, 3. Does it make sense that quartile number 1 had to be 25? 1, 2, 3. 1, 2, 3. Did it make sense that quartile number 3 had to be halfway between 43 and 47, which would be 45? Without a calculator, you are not dead in the water. You did not have to do a damn thing about adding the numbers together. All you had to do was fold over the list and count. You had a simple division problem to do. Automatic calculator is not going to pass as a viable excuse. But the calculator does the work for you a lot quicker. But the responsibility you accept is making sure the data went in right. So that verifies that 5-number summary that we got of the problem. Now they want interquartile range. By definition, interquartile range is Q3 minus Q1. And that means in this particular case that I'm taking the value 45 minus 25, and that's going to give me 20. If you make a mistake with data, can you see that your interquartile range is going to suffer? And is that going to make your fences going to suffer? Does that mean you're going to lose everything in the problem? The road to hell should not be paved with good intentions. It is still the road to hell. So if you don't be careful with the calculator, there is no salvation. There is very little partial credit because that is the responsibility that you accept. This problem you can get a little bit of partial credit on because the calculator doesn't give you the fences. but I know how to find them. The lower fence says that I'm too small. So I start with Q1 and I back out what was agreed upon by taking 1.5 times the interquartile range, which means in this case that I'm taking Q1, which is 25, and I'm subtracting 1.5 times the interquartile range, which I already know to be the value that came from above. Oh, and you don't have to be a freaking genius to do that because the calculator will do it for you. 25 minus 1.5 times 20. So I came up with a value of a -5. Don't freak out if you come up with a negative value. You look back at the data set and you said, wait a second, the smallest value in my data set was 10. How can I have a lower fence of a -5? It is an artificially designed value, not a value that was part of the data set. An artificially designed value that said anything in your list less than a -5 is considered to be excessively small, and therefore it fits the definition of an outlier. Outliers are the values that are excessively small, that we've agreed upon statistically, and you can't change what statisticians did 200 years ago when they set up this formula. So if you don't like it, you can't create your own formula, you can get the rest of the world to buy into it. Ain't gonna happen. Upper fence, too big. Q3 plus 1.5 times the interquartile range. So it now takes 45 plus 1.5 times 20, and that ends up giving us a value of 75. And any value greater than 75 is excessively large. There are no guarantees that you are going to have any outliers. But if there are outliers there, you must find them. It's a scavenger hunt. It's a hide-and-go-seek thing. Every value in the data set, which now makes it attractive to have the data set sorted because it's easier not to have to play hide-and-go-seek through a large data set, every value that's greater than 88 is considered to be an outlier. So question, is there an outlier in this data set? There is an outlier. 88 is an outlier. If there's more than one, list them all. Not just the biggest, baddest one, or the smallest, ugliest one, all of them. It is possible that you may have no outliers, and that would be an option in the multiple choice question. But if there are outliers, there'll be a box to put the outliers in, and the instructions will say, separate your answers with a comma as needed. It won't care what order you put them in, it will care that you get all of them. Now, all of this leads to our ability to be able to draw something called a box plot. So I'm going to cheat a little bit here, just a second. I'm going to take this screen and I'm going to clone that screen. And I'm going to do a little bit of fancy footwork in here. So my sheet, this sheet and the previous sheet are exactly the same. But I didn't want to have all the stuff on this sheet now, so I'm on my second sheet and I'm getting rid of all of this stuff.